How does metal become parts so precise? A block transformed to something nice. It starts with code, a language machines can read. G-code tells the tool exactly where to lead. The workpiece locks down steady and tight, while spinning cutters prepare to bite. CNC, computer numeric control, turning blocks of metal into something whole. From rough to smooth, from code to steel, watch precision engineering become real. CNC, every cut's a calculation. Mathematics meets creation. Those cutters spin with teeth like tiny knives. 8,000 to 60,000 RPM comes alive. Each tooth removes a chip, a sliver, a flake. As it passes through, material breaks. Remember that G-code from the start. Now it's driving every single part. Linear moves for straight line cuts, circular arcs when the path curves up. CNC, computer numerical control, turning blocks of metal into something whole. From rough to smooth, from code to steel, watch precision engineering become real. CNC, every cut's a calculation. Mathematics meets creation. Here's the magic hidden in the machine. The controller calculates what's in between. Thousands of points don't make curves flow, point to point to point in a perfect row. Feed rate controls how fast we go, cutting speed determines the show. Rough it out at 12,000 RPM, then finish smooth at 8,000 again. Precision down to 1,000th of an inch. 0.025 millimeters, not a pinch. Because the code breaks paths into tiny moves, the machine creates perfectly smooth grooves. Multi-axis motion, 5 directions at once, common shapes at once, seem like stunts. Without this digital control so tight, we couldn't make parts that fit just right. From aerospace to your phone in your hand, CNC precision makes it all withstand. CNC, computer numerical control. Now you see how code becomes a goal. From rough to smooth, from math to steel, precision engineering completely real. CNC, every cut's a calculation, where mathematics meets creation. 1,000th of an inch every single time. That's the power of machines that read in line.